So just as a quick recap, let's compare the you from 10 minutes ago to the you of now. The you who now knows about conservation of energy and gravitational potential energy. Well, even 10 minutes ago, you could have solved the problem with, let's say, a ball dropping down in free fall. 10 minutes ago could have solved that, and now could have solved that. You know everything that you need to know to describe this motion. What about an inclined plane? Well, 10 minutes ago, I think you could have solved this. You know how to break forces down and solve for acceleration. And so now I assume you could solve that as well. But an inclined plane isn't a very realistic shape. How often in nature do you see a hill that's perfectly flat at one single angle? Not very often. More often what you see in nature is weird, strange shapes like this one. And if you have a block of mass m on a hill like this, could you calculate the speed of the block when it gets to the bottom? I think 10 minutes ago, you may not have been able to do that, but now you can. And how are you going to do that? Well, as long as you know the height of the hill, you know that as the block slides down here, well, its potential energy will be described by this equation, m times g times h. So as h goes down, potential energy will go down. But energy is conserved. It can't be created. It can't be destroyed. So if potential energy is going down, kinetic energy must be going up. And in fact, at the very bottom of this hill, once the block has gotten all the way down here, h is 0, so all of the potential energy is gone and converted into kinetic energy. We can say that mathematically by saying that the potential energy the block had up here is equal to the kinetic it has down here. Or mgh equals 1/2 mv squared. And what do you know? The math tells us the mass of the block doesn't matter. We can solve this equation for v to get this wonderful answer. The velocity of this block at the bottom will be the square root of 2 times g times h. This answer is remarkable. It doesn't depend on the mass, and Galileo knew motion shouldn't really depend on mass. It depends on the acceleration due to gravity, as we expect. If it's higher, well, the speed is higher. It also depends on the height of the hill. Slide it down a higher hill and the velocity is greater. This makes a lot of sense. Now that you're so much smarter than you were 10 minutes ago, it's time to put these skills to use and solve some problems.